Hello, this is Ms. DB. In this video, we are going to look at an activity called Exploring Slope. So we're going to work with the Explore Learning, the Gizmo site for this. So the directions on how to log in are at the bottom of the folder. Let me know if you have any problems with that. And the one that we're going to be doing is right here called Slope. You can either click on Slope or Launch. It opens up the same Gizmo. And now let's go over here and look at the directions on the worksheet. Alright, so it says that in the slope gizmo you can find the rise, run, and slope of the line through 2 points. I'm going to click on Show Rise and Run. If you hover over a point, you will see its XY coordinates. So if I hover over this, I see that the coordinates right now are at -2, -2, and this one's at 3, 3. I can also see the coordinates right here on the sliders. So you can move a point by just clicking it on the graph and dragging it around, and the slider moves at the same time. Or you can adjust the slider. Or you can put a number here, and it'll change the point. So there's those 3 ways. Let's see, the directions say to drag the red point to 2, 1. So right now it's at -2, so I need to go to 2, 1. And you want to make sure that the coordinate is exactly what they tell us it is, and it's 2, 1, so that's correct. And the blue point to 5, 7. So right now it's at 5, 4, so I need to go up, up, 5, 7. All right, turn on Show Rise and Run. I already did that. So Rise and Run is when the green line and the purple line show up. If I didn't have that on, it would just be the 2 points. Okay, so right now I see Rise and Run. That's really what slope is. It's how steep a line is. And the rise over the run is how we write the ratio for our slope. All right, so our rise over our run right now would be 6/3. And let's see, is that all they want us to do? Rise is the vertical distance between the 2 points. Run is the horizontal distance. Change the Y1 and Y2 sliders. This will move the points vertically. So I'm going to change Y1. I'll just go down a little bit. You can see the rise is getting longer as I go down. And I can change Y2. Oh, now they're getting closer together again. So it says, how do you find the rise between the 2 points? Instead of just looking at it and saying 7, I can try to figure out how did they get 7. Well, the y value of the red point is -8, and the y value of the blue point over here is -1. Whoa, I didn't mean to do that. Whee! I'm going to move my points so that they are both positive, so it'll be easier to look at this a little bit. There. Now let's look at the y value of the red point. It's 7. The y value of the blue point is 2. And the rise is -5. So it looks like there's something to do with subtracting or finding the difference between the 2 values. Can the rise be negative? Well, it's negative right now, so that's a yes. Change the x1 and x2 sliders. Okay, x1 is this one, and x2 is this one. So you can move them around however you decide to. And then it says, how do you find the run between the 2 points? The run is the purple. So the red x value is 2, and this one is 5. So it looks like, again, you find the difference, or you subtract them, and you would get the run. Then they ask, can the run ever be negative? Well, here's an example where the run is negative. So it can be. All right, now we're going to get ready for some good questions here. Make sure your rise and run is turned on. And here they show that they're subtracting, so that was correct. The ratio, rise over run, describes the steepness of a line. This ratio is called the slope of the line. So it's a special ratio called slope, and it's used for lines. So we're going to experiment with a variety of lines. We've been doing that already. Then answer the questions below. Be sure to talk about rise and run in your explanations. Which is steeper, a line with a slope of 2 or a line with a slope of 3. I'm going to turn on slope computation so I can see the slope. This one's slope is 0.5, so I need to get a steeper line, I think. Let's change these and see if I can get a slope of 2. There's a slope of 2. Now look at that line and think about it. And now we're going to make a slope of 3. Oh, that's too much. 3. So which one was steeper? You might even want to take snapshots of these so that you can look at them side by side. Here's a slope of 3. I'm going to do a quick screen capture of this. I think I'll keep the... No, I'm just going to do the graph. It'll be smaller and easier to fit. There's my slope of 3. So that's, if you were climbing that hill, that would be pretty hard to climb. That looks pretty steep. And I'm going to paste that into my worksheet just so I can see them side by side. And now I'm going to make a slope of 2. I think it was, yep, there it is. Okay, so I just had to move that red point a little bit. And now I can see them at the same time. So the slope of 3 is on the left side, it's over here. And the slope of 2 is on the right side. It looks to me like the slope of 3 is steeper. It would be harder to climb this blue line than it would be the blue line over here. All right, so let's keep going. Which is steeper, a line with a slope of 1/2 or a line with a slope of 1/3? Okay, so we need to make our slope different so that we can check. Right now our slope is 0.5. That's the same as 1/2. 4/8 is the same as 1/2, or negative 4/8 is the same as 1/2. So that's our slope of 1/2. Now let's try to find a slope of 1/3. I'm going to take a picture of this again so I can look at them at the same time. Copy. And I will get rid of that one. Put in the slope of, that's my slope of 1/2. Now let's change this one over here to 1/3. 1/3 is a decimal, because this slope is being calculated as a decimal right now, would be 0.333333333333. So I'm going to try to get that as my new slope. Let's see, what if I change, oh, that's pretty close right there. Okay, so here is my 2 lines to compare. Which one looks steeper? The slope of 1/2 looks steeper. It would be harder to climb that, although it's a lot easier than climbing a slope of 2 or 3, but it's still steeper than the slope of 1/3. So complete this sentence. The steeper the line, what do you think? The higher the slope, or the bigger the slope, or the greater the slope? Something like that. Because our slope of 3 was steeper than the slope of 2. Our slope of 1/2, 0.5, is greater than the slope of 0.3. So they're greater. The steeper the slope, the greater the line. No, the steeper the line, the greater the slope. All right, now we are going to look at, we're going to graph many different lines that go uphill from left to right. So pay attention to the rise and run as you do so, then fill in the blanks. So we already have one that's going uphill right here. We can change this to make other lines that go uphill. There's one that goes uphill. Nope, that doesn't go uphill. That goes uphill. That goes uphill. So there's lots of different lines that go uphill. Let's make the blue dot up here and the red dot up here. All it does is make the triangle above it instead of below it. This is still going uphill. So for uphill lines, if the rise is positive, that's what I have right now. The rise is positive. The run is also positive. When you put the blue dot on the bottom and the red one on top, you're still going uphill in this example. We're still going uphill from left to right, but now the rise is negative and the run is negative. Because slope equals rise over run, the slope of an uphill line must be, you're going to fill in positive or negative there. If you get negative divided by negative, that's a positive number. And of course, a positive when we had the blue dot on top. A positive divided by a positive is also a positive number. Okay, then you're going to make some downhill slopes. So that means as you go from left to right, you will go down the hill, like you're sliding down the hill instead of climbing up it. Here's one example of a downhill slope. We have a rise that's negative and a run that's positive. Let's put the red dot on the bottom and the blue dot on the top and make another downhill slope. There's another downhill slope. This time the rise is positive and the run is negative. And when you have a positive number divided by a negative number, or a negative number divided by a positive number, the answer will be negative. We learned that when we talked about integers in the last chapter. All right, now we're going to look at lines that are flat, meaning horizontal. So let's see if we can move this so that the line is, oh, there we go. What happened? The rise is gone. If you look at the computation, the rise is 0. It doesn't go up or down, it's just 0. They're at the same height. The run is -10. If I move them close to each other, I still have a rise of 0. My run is just -4 now. 0 divided by any number is 0. That's very interesting. So you decide what is true about the slopes of all horizontal lines. Now let's look at some vertical lines that are straight up and down. Look at that, the run is gone, the run is 0. But when you go to put that into a ratio, you're not allowed to divide by 0. So we have to write undefined. So a vertical line has a slope that is undefined. And the reason is that there is no run. Run is 0. That's supposed to be under the explain section. And dividing by 0 is not allowed. So we have to say that it's undefined. Number 5 says, how can the coordinates of 2 points on a line tell you if the line is horizontal or vertical? I didn't even look at the coordinates, but look here. The coordinate of the blue point is 7, 4. The coordinate of the red point is 7, -3. What if I make a different vertical line? Do the x-coordinates match still? Now I have another vertical line. My x-coordinates are 11 and 11. So that might tell you what's true in a vertical line about the coordinates. In a horizontal line, let's look at the y values. We have 2, 4 and 11, 4. This time the y values are the same. And we can even make that be somewhere else, maybe. Here, I'll make a vertical line below the x-axis. Okay, my y coordinate is -2, and my y coordinate here is -2. So for a horizontal line, the y coordinates will be equal to each other. Okay, so have fun exploring lines and slopes. And there'll be another assignment where you practice some more work with slopes. Thank you very much and have a great day.